Alright, so the next conic section that we're going to discuss is the parabola. We're not going to go into a ton of detail with the parabola. I think for the most part, as long as you know how to graph parabolas, you know the definition, you know some real world uses, I think it'll be okay for what you'll need to know about parabola graphs or the parabola conic for the most math that you'll end up doing, okay? So by definition, a parabola is the set of all points in a plane such that the distance from the focus to the directrix is the same. This line down here is our directrix, and this coordinate within the parabola is our focus. So if I were to pick any coordinate on the parabola and measure the distance to the focus, and then measure the most direct distance to the directrix, those distances would be equal. Okay, if I picked a different coordinate here, again, that distance here would match this distance here. Okay? So all points in a plane such that their distance from the focus and the directrix is the same. So that's the definition of a parabola. We're not actually going to find the location of the focus for a parabola. We're not going to find the equation of the directrix either. Like I said, we don't do a lot more with parabolas than what you kind of already know. As long as you know how to graph basic parabolas, I think we'll be fine. Some real-world uses of parabola. You guys remember any sort of projectile motion, if you throw a ball, hit a ball, whatever, the path that that ball takes is a parabola. Another one that I like to talk about here is, kind of like a satellite dish is shaped like a parabola. If you think of a satellite dish and how it works, okay, so the satellite dish is more than just the dish itself. There's a little receiver within the dish, right? Okay, if you look closely at it, well, that receiver is kind of set up in a specific spot, the focus, because as those waves come in, the parabola is shaped such that it'll hit that parabola and reflect right to that receiver. Whether it hits here, it'll always reflect right to that receiver, and that's essentially how you get your satellite TV. Okay, that's why it's shaped in the way that it is, so that it bounces right to that receiver all the time. Okay, so it's another use of a parabola, and specifically the focus within the parabola is used to gather all that signal. Okay? Questions on definition, usage, and so on? I know you guys have read about that stuff anyway too. Just alright, y equals x squared. I mean, write down as much as you feel like you need here, guys. I'll go pretty quick through this. Y equals x squared, that's our parent function. I think most of us would know how to graph y equals x squared. What if I change the function? What would this graph look like compared to this one?
Go right to up 4.
Yep. Right 2, up 4. What if I throw a negative sign out in front?
Flipped upside down.
Flipped upside down. Probably be upside down, right?
Yeah.
Okay, so you guys kind of remember that stuff earlier in the year. We talked about transformations.
How would you get a horizontal?
Okay? The parabolas we've worked with have all been functions, meaning they pass the vertical line test. Only one vertical line would pass through the parabola at one location. If we turn the parabola sideways, it was exactly what Mason just asked about, we all of a sudden then would have something that is not a function, okay, but it is still an equation that we could potentially use. So y equals x squared, as I've already talked about, is a parabola that looks like this, or one of our 10 parent functions that we kind of memorized. You can have sideways parabolas. They are not functions anymore, but how will you know when you have a sideways parabola? Well, basically when the y is squared instead of the x. Okay? So x equals y squared. When I did this in the other class, I said, okay, why don't you graph for me x equals y squared? They didn't know how. I said, okay, well, let's think back. When you were first taught on how to graph something, when you didn't know any shortcuts, what did you make? A table of values. Okay? So if I give you an equation and ask you to graph it, well, make a table of values, and instead of plugging in numbers for x, plug them in for y. So what I had them do is they kind of plugged in, not in the order that Miss Carey would have taught you, the -2, -1, 0, 1, and 2. Okay, but I mean eventually they decided to plug those in. But they plugged those numbers in for y, see what they got for x, and they went and plotted the points, and voila, we have a sideways parabola. Okay? Let's graph this one.
So would it be turned that way?
Well, Mason's got a guess.
So then turn that way and then up through? So then the,
So something like this.
yeah.
Okay? Anybody else want to guess? Nobody's brave?
Seems right.
Alright, I like it. Let's try it. Let's make a little table of values and see if he's right.
That was right.
Pick a number, plug it in for y.
-2.
-2.
So,
-2 squared is 4. Opposite of 4 would be -4. Add 3. -1.
and then -1.
-1. -1 squared is 1. Opposite of 1 would be -1 plus 3.
-2. Or not -2,
2.
0.
Plug in 0. Up comes a 3. 1.
Square.
2.
And then -2. Same thing. -1. It works.
Plot these points. -1, -2.
Oh. No.
2, -1.
Wait.
3, 0. 2, 1.
Oh no, I know it's that way,
-1, 2.
Wait, why do you have 2 -2s up there?
Whoops.
It's still the same, right?
Positive 2, right?
Yeah.
Positive 2 gives me a -1.
but you did it right.
Yeah, it would still be the same because he's squared.
So
You were close. It opened this way, but it actually moved right 3. The reason why is because now we're writing x equals. This did
I see what it's.
do this to it.
mhm.
What would adding 3 to all of the x values do?
It would make it right.
Go right?
No.
Yeah. So, alright.
See, I told you it wasn't
If you're
right.
able to think of it that way, you could come up with your graph pretty easily. But I do strongly recommend making a quick little table of values all the time. Okay? So, again, know the definition, know the usages, know the satellite dish thing that I talked about. Kind of be able to explain that. Know how to graph it. And I believe that's pretty much it. Okay? That's the one we did in the other class.
Works for me.
Simple enough, parabolas?
Yep.
Scold.
Just for practice.